Hey there. Today we're going to look at angles of elevation and depression. This is just a continuation of SOHCAHTOA. It's just application. So you're not going to be given a right triangle. You're going to give a scenario that's going to create a right triangle. You have to draw the triangle and then use your SOHCAHTOA. All right. It's all based on angle of elevation and angle of depression. The angle of elevation and depression are both based on, like, are you looking up at something or are you looking down at something? That angle at which how high you have to look up or how far you have to look down, that's the angle we're looking for when we do our SOHCAHTOA. And it's different. You always draw, like, you're going to draw this right triangle and it's always going to come out of your eyes. So this dog right here, here's his eyes, here's his line of sight, his eye level. And if he's looking up at the bird, then this is the angle of elevation. And you can see right here, then we would create this right triangle business. However, if you're up high and you look like the bird is and you're looking down at the dog, well, the angle of depression, again, is from the eye level, so it's how far. So here is the angle. When they say the angle of depression is 20 degrees, you would draw the angle up here. And we would draw a triangle that looks like this. This would be our right triangle. All right, so let's practice that a little bit, just making sure that we're using the proper angle. So angle 1, what do you think? Would that be an angle of elevation or an angle of depression? All right, well, the angle is up here by the bird. So the bird is looking down. You can see here looking down at the person in the balloon. So if you're looking down, that's an angle of depression. So we would fill in here angle of depression. Of the bird to the person. Actually, yeah, the person. Let's do that. Okay. Oh, what did I write there? Bird, not berg or whatever I've got there. This is a bird. Sorry, bird. Okay. Number 2 is an angle of, okay, if you look right here, this is your angle 2. And so this is the person looking up, because here's the line of sight. There's your line of sight. And they're looking up. So we would say that this is an angle of elevation. Of the person looking up to the bird. All right. You try the next 2. Pause the video. You fill in the next 2. Come back and check, and we'll move on. Okay, take a look at mine. I tried to color code it there so you could kind of see what was going on, and hopefully you agree. If not, take a peek at my answers. I'm moving on. Okay, so now we don't have a picture. We have to draw the picture. It says a tourist looks out from the crown of the Statue of Liberty, approximately 250 feet above the ground. The tourist sees a ship coming into the harbor and measures the angle of depression as 18 degrees. And there are devices and tools that you can use to measure that angle. It says find the distance from the base of the statue to the ship out to the nearest foot. Okay, so here we go. We're going to draw the Statue of Liberty. There's the torch, whatever. Okay, all right, so that's beautiful. Here's my person standing on the, I should draw the crown, okay. The person is standing inside the crown there, and they are looking out at a ship out here. Now, you always have to draw like that. What is it that you're looking at? You draw that line, but you also will always draw your line of sight. And so the person was here, it said. So that's your line of sight, looking straight out, and then you have to finish out your right triangle. This is your angle of depression because you're looking down, and that's 18 degrees. It says a tourist, what's the 250? Oh, the 250 is the height. Now that height is the same here as it is here. So it doesn't really matter where you draw that. Since I drew it out here, I'm going to put the height of my statue out here on the right. So it's on my triangle. So that's 250 feet. And the question is find the distance of the base of the statue to the ship. That's this distance, which would be the same up here. So that's my X. All right, now I'm just going to go do SOHCAHTOA. Looking at this, with the given angle 18, it looks like I have the opposite side, the 250 is the opposite, and then I have the adjacent, because here's my right angle, so this is my hypotenuse, and I am not using the hypotenuse for anything. So it's opposite and adjacent. Do you know yet off the top of your head what that is? Tangent. Tangent of 18 is equal to opposite over adjacent. Multiply both sides by x, and then you're going to have an x times tangent 18 equals 250. Come back and divide by tangent of 18. In my calculator, I'm going to type in 250 divided by tangent of 18. And I have x equal to 769. What are we rounding to? To the nearest foot. Okay, 769 feet. That's how far apart the ship is from the base of the Statue of Liberty. Okay, let's try another one. The world's tallest unsupported flagpole is a 282-foot tall steel pole in Surrey, British Columbia. All right, got myself a big flagpole. And I know that it is 282 feet tall. Now the shortest shadow cast by the pole during the year is 137 feet long. So here's my shadow, and it's 137 feet. To the nearest degree, what is the angle of elevation of the sun when casting the flagpole's shortest shadow? The angle of elevation to the sun. Well, if my shadow is down here, then my sun is up here somewhere. And so they're looking for this right there. Here's your angle of elevation looking up to the sun. All right, let's look at what do you think here? Which sides are involved in this problem? All right, again, hypotenuse not being used. It's opposite and adjacent. So I'm going to do tangent. But I'm looking for my angle this time. I don't know what we want to call that. I'm just going to call it angle A. Tangent of angle A is equal to opposite, 282, over adjacent, 137. Now remember from yesterday that when you're looking for the angle, that's when you have to, it's like you're trying to get rid of this tangent right here. To get rid of that tangent, you have to do inverse tangent. So I'm going to type in my calculator, second tangent, and then I'm going to do that fraction, 282 divided by 137. And I get a 64-degree angle. Okay, last one. You sight a rock climber on a cliff at a 32-degree angle of elevation. So you're looking up at this rock climber. Your eye level is 6 feet above the ground, and you're 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? All right, so here's here's kind of like your rock wall thing, and here's your climber climbing up there. And then you're down here looking up at this rock climber. It says that you have a 32-degree angle of elevation. But what's different about this one is it tells you about your eye level. Here's your eye level right here, which happens to be 6 feet here. All right, and so we haven't even acknowledged the fact that, oh yeah, your eye level isn't really at the ground. Sometimes we ignore that. If it's something very high up in the sky, if you're looking at an airplane, that 6 feet isn't going to make that big of a difference. If it's something a little bit lower, that 6 feet does make a difference. You're only going to care about it if they care about it. If they say something about where your eye level is, then you'll have to take that into account. All right. So I'm going to draw this triangle then. From my eye level, I'm going to always draw that. I'm going to draw what I'm looking at. Here's the right triangle. Now, it says that the angle of elevation here is 32 degrees. I'm looking up at the climber. And it says I'm 1,000 feet from the cliff. What's the height of the rock climber? So I'm looking for this right here. All right, there's my angle. Looks like I've got another opposite and adjacent. That happens a lot with these types of problems. You don't use the hypotenuse a lot. So tangent of your angle is equal to opposite over adjacent. Take it times 1,000. This is the one where I just get to type it in the calculator and I'll have my x already. So I'm going to do 1,000. I'm going to multiply it by the tangent of 32. And I get 624. Doesn't really say what we're rounding to. I'll give it one decimal place. I got a 624.9, it looks like. But that's not the total height of this rock climber. That's this x side of this triangle. What do you suppose I need to do with that x? I need to add the 6 into it. Okay, and again, this looks pretty high to me. I'm not sure the 6 feet is that big of a deal, but we're going to add it in. We're going to give him every bit of that rock that he climbed. So I'm going to add 6 for that height. So now my answer is 630.9 feet. And that's how high he is off the ground. All right, a lot of SOHCAHTOA. Just have to draw your own triangles for it. Good luck.